Alright guys, so for today's lesson we're going to look at central and inscribed angles. I'm probably going to split this lesson up into two videos for you guys to watch. Starting off first with central angles. So as you can see there in the box, it says a central angle is an angle at the center of a circle with endpoints on the circle's circumference. So like here in this example on the right, you can see that A and C are on the circumference, and then on the inside it makes this angle. So that's what a central angle is. It's just on the inside of the circle with touching the center. With that, we're gonna some arcs are going to be made from their angles, and we got to know what type of arcs those are. So we got different kinds. We got minor arc, major arc, and then we got semicircles. So starting off with a minor arc, you can think about this as basically the smaller arc. So if you see here from A to C, that makes the smaller arc there, so that's what we call a minor arc. And so we label this by the endpoints, which would be A and C, and then we just put a little arc on top of it. And then as it says up here, we just have to look for the measure of an arc. We can look at the measure of the central angle because they're the same. So this angle inside here was 110 degrees, so this arc measures 110 degrees. Okay. Next we got major arc, which is basically the bigger arc. So here we have our inscribed angle, but the major arc is made by the outside here. So with that, we would still describe this as arc D, and then because it goes through E, you can put that there, DEF, and then put the arc on top of it. Okay, this one, we don't know this whole entire outside angle just right off the bat, but we can calculate it pretty easy because we know this inside is 60. So what we can do is we can take 360, which is how many degrees are in a circle, and subtract 60 from it, and that gives us 300 degrees. And so that's a major arc, or the bigger arc. Next we got semicircle, which semi means half, so these are basically the arcs made by half the circle. So we got that one using different colors, then we got that one there. So here we got to include which one's in the middle because our endpoints are going to be J and L for both of these, but we have to include which way points we're going through. So one of these arcs could be JKL with the arc on it, or the other one could be JML. Okay. And then since these are both half the circle, the measure is half the degrees of a circle, so basically we have 360 degrees, and then you just divide that by 2, so those guys measure 180 degrees. Ta-da! Okay, so now guys, we're going to do a bit of like chasing the angle, where we want to figure out, or I guess the arcs for these ones. So in circle F, if the measure of angle DEF, so basically that means DEF is 50 degrees, which we got, and CF and FB are perpendicular, find each measure. So we honestly are given those knowing that this is 50 degrees and then that, because they're perpendicular, is 90 degrees. Okay, so now what we want to do is we want to find some different angle measures here. So we got to kind of start to chase our arcs. I guess arc measure, not angle, arc. So first off, we got the measure of EA. So we got to figure out what that guy measures. But so to be able to do that, one thing that'll help us is if we look at this line right here, because, hey, that's a diameter. So that means that makes a semicircle, and so this total arc length should be 180. So this total here should be 180, but we only have 50, so what we can do is we can take 180 minus 50, and that gives us 130 degrees. So that means that measure of MEA is 130 degrees. Okay. Now we got the measure of arc CD. So we just got this one right here. So for this one, guys, we know that we got 90 degrees right there. And this right here makes a semicircle. So this whole distance from E to B is 180. But we know that we now have 90 degrees and 50 degrees. So to figure out what CD is, we just have to take 180, subtract 90, which that gives us 90, and then we have to subtract 40, or 50, sorry, which gives us 40, and voila. So the measure of CD is 40 degrees. Okay, let me kind of erase some of this to clean it up a little bit. Okay, let's put that blue back in there. Okay, let's put in what we found. So we found that EA or AE is 130 degrees. We know that this is 90 degrees right there. And then this one right here is 40 degrees as well. Okay. So what we have to do now for this next one is find the measure of ACE. So we got to find the measure of this whole thing right there. Okay. So we know part of it, right? We know 50, 40, 90. But we got to figure out what this section is right here to be able to figure out that whole thing. One thing that could help is that we know, again, this is a semicircle. So 40, 90, and I guess we could call it our X or unknown. Those are going to equal 180. So we could do 180 minus 90 again, which is 90, minus 40, which is 50. So we know that this right here is 50. So again, to figure out what this whole thing is, we would have to do 50 plus 40 plus 90 plus 50. So again, 50 plus 40 is 90 plus 90 is 180, and then plus 50 is 230. So this right here is 230 degrees. Okay. Lastly, we have to find an arc that is congruent to DE. So again, let me clean this up a little bit. AD, sorry. So AD was 50 degrees. What other arc is 50 degrees? BE right there. So how we would write this, that these two are congruent, is you would say that AD, or arc AD, is congruent to arc BE. Okay, so we're chasing the angle. We got to find the angle. Okay, so here, find the arc measure or angle of the arc indicated. So for this first one, we got to find our question mark, which is this arc right here. But we know that angle is 112 degrees, so 112 degrees. Nice and easy. Next, we got to find VWU. So we got to find the measure of this angle right here, which would be the same as that arc. So we'd have to find what that arc is. Well, that arc is on a semicircle right here. So we know that that semicircle is 180 degrees. So we basically just got to do 180 minus 61, which gives us 119 degrees. Ta-da! Okay. Next, we want to find the measure of arc FDE. So we want to find F to D to E, this whole big guy right there. So we know that's 95, but what do we know about this arc right here, D to F? It's a semicircle. And in the semicircle, it's 180 degrees. So we got to do 180 plus 95. And that gives us 275 degrees. Ta-da! Okay. So now let's make it a little bit more complicated. Let's put in some variables here. Okay. So with D here, find the measure of angle FHE. Okay, so we got to find that measure. And we know that the angle on the inside, is 2x plus 1. And we know that the arc is 9x plus 11. But the angle is equal to the arc, so we can just set those two equal to each other. So we can do 11x minus 1 is equal to 9x plus 11. And now we just crunch our numbers. So we solve, we subtract the 9x. That gives us 2x minus 1 is equal to 11. Got to move that 1 over, so we add 1. We get 2x is equal to 12. Divide by 2. And we get x is equal to 6. Okay, so that's awesome. But the thing is, it's asking us for the measure of the angle. So what we have to do is take that 6 and plug it in for our x for the angle. So you have to do 11 times 6 minus 1. 11 times 6 gives us 66. Minus 1, we get 65 degrees. Ta-da! Okay. For the next one, we're going to have to remember back to our different types of angles to help us with this one. but we want to find the measure of arc ML. So to do that, we know that ML is made by these two lines right here, and those two lines make these angles. But what type of angles are those? Those are vertical angles. And because they're vertical angles, they're the same, which means that these two are the same. So we can set them equal. So we can do 3 plus 11x is equal to negative 4 plus 12x. And now we solve. So we subtract 11x, gives us 3 is equal to negative 4. 12 minus 11 is 1, so we just have plus x. Solve for x by adding 4. So we get x is equal to 7. But we don't want to, it doesn't say solve for x, it says solve for the measure of LM. So what we got to do is take 7 and plug it in for x down there. So what we're going to do, we have negative 4 plus 12 times 7. And so that gives us that's equal to negative 4 plus 84, which is equal to 80 degrees. Okay. On this next one right here, gotta kind of think this one through a little bit. So it says find the measure of IH, of arc IH, so we want to find that right there. Okay. We know that the arc is equal to x plus 130, so therefore this angle is equal to x plus 130 as well. So we know this, we know that angle is 130, we know that's negative 21, and we know x plus 130. So we know all three of the angles. Well, if we add all three of those angles, what do they add up to? How many total degrees are in a triangle, or in a circle, sorry? 360. So what we can do is we can take 130 and then add in negative 21x. So we basically, oh, excuse me, it's early. We'd be subtracting 21x, and then we'd have to add in x plus 130. And all of those would be equal to 360. Okay. So now we just have to solve. So what we can do on the left is combine like terms. So we got 130 and 130 gives us 260. Negative 21 and x gives us negative 20x. That's equal to 360. Okay, well we have to move the 260, so we subtract 260. Subtract 260. Gives us negative 20x is equal to a hundo, and now we have to divide by negative 20, So that gives us x is equal to, it's going to be negative, but it should equal negative 5. But we want to find the measure, so what we got to do is take negative 5 and plug it in for x. So we got negative 5 plus 130. That's equal to 125 degrees. And voila. There we go. All right. So that, guys, are central angles. Now in this next video, we're going to look at inscribed angles.